Well, welcome to today's Scylla webinar. Today we're going to be talking about Scylla Cloud. I'm Michael Schulman. I'm the Senior Product Marketing Manager here at Scylla, and I'm based in Palo Alto, California. I'll be joined a little later by Zach Leviatan, who is Head of Product Management, and Zach is based in our Israel office. So this is what we're going to cover today. As a note, we will be showing some benchmarks and doing a live demo of Scylla Cloud. For those of you who are not familiar with ScyllaDB, what we create is a real-time big data database that is based on Cassandra. It is a drop-in replacement for Cassandra. Basically what we did, we took Cassandra and rewrote everything in C++ to get maximum performance from the underlying servers. We get about 10x the performance and consistent low latencies, and we're going to show you some benchmarks to prove this. We've had an open source and enterprise edition for a few years now, but today we're going to be talking about Scylla Cloud, which is a database as a service. On the right-hand side here, you see a growing list of our customers who are using open source, enterprise, or Scylla Cloud. We've talked to a number of industry analysts and experts, and what we have learned over the past year is that 90% of organizations are increasing their cloud budget for critical workloads, and this includes moving databases into a cloud infrastructure or as a cloud service. Most of the data that's being created is unstructured data, whether it be text, video, images, URLs, or whatever. Okay. And if you look at this unstructured data versus structured data, 50 times higher growth for unstructured data is being stored today. And organizations are having challenges in managing this data. It's very complex to keep track of the data, where it is, and access it. But companies want to do this and need to do this while reducing their expenses. They're having challenges with existing cloud database as a service implementations. So we're going to talk about how we overcome many of those challenges. Some of these are just not up to the task in terms of the performance that they deliver in the cloud. So what do we have today? We're going to talk about Scylla Cloud, which is a fully managed database. You get the performance and the reliability of Scylla Enterprise all in an environment where Scylla manages everything for you. So let me talk about a few of the things that are part of Scylla Cloud. The first is that Scylla installs, manages, and supports the product by our experts around the world. We configure the installation for maximum performance based on the hardware profile that you choose. We ensure and protect your data and make sure that your data is always available. As we've mentioned before, Scylla Cloud is automatically set up for high availability. For all of these features, you don't have to do anything. We take care of all of this for you with Scylla Cloud by default. In terms of support is included with Scylla Cloud. You don't have to pay anything extra for this. We manage and operate this by our skilled cloud DevOps team, as well as our Scylla engineers. And as I previously mentioned, you'll always be on the latest version of Scylla Enterprise. We take care of much of the day-to-day automatic checks, health checks, and do the managed repairs. We take care of all of this for you. And when you get the complete Scylla support stack, we give you the tools that are needed to manage, to make sure everything is working smoothly. And we will only contact you if there's a critical issue that we need your input on. In terms of backup as part of Scylla Cloud, there is a possibility that you may need to roll back and get to your data from a day, 2 days, or maybe 1 week ago if something happened with your application. So what we do, we store 5 of these backups, and by request we can bring this data back for you. In addition, we limit the upstream bandwidth so that we don't to the backup system, so that we don't affect your running performance in Scylla Cloud. We take protecting your data very seriously. So here's a list of some of the steps that we take on your behalf as part of the service. You don't have to do anything to take advantage of this. So now let's look at a few of the Scylla Cloud benefits. And then we'll show you some benchmarks. So here's a summary of the benefits that are part of the Scylla Cloud implementation. The first is high performance. We can get millions of operations per second on a single node, and this eventually means less cost for you. In terms of low latencies, we can deliver consistent single-digit millisecond P99 latencies. What this means for you is that you are guaranteed that your customers will get the response that they are used to and that they expect. We're Cassandra compatible. Since we're a drop-in replacement for Cassandra, the full Cassandra ecosystem is available to you right away. No lock-in. We run in different environments so that based on what you need, you can move your Cassandra data, your Scylla database to different environments, and we'll show you later on how to do that. And we're less expensive. In the benchmarks we've run versus Amazon's DynamoDB and Google Cloud Bigtable, for a given service level agreement, we are 10 times less expensive. So let's look at each one of these in a little more detail. So based on a real world use case from a customer, to get a certain level of performance, they needed 120 of the i3.2XL large servers in AWS. We then ran the benchmark, and we saw that in conjunction with the customer, that they only needed 24 of these same servers. That is a 5x reduction to get the same performance. It's 5 times less cost to go get 24 i3.2XLs as compared to 120. But then we took it a step further. What we did, since we scale up as well as out, by using larger nodes, we were able to get the same performance. So it's really up to you in Scylla Cloud whether to use smaller systems or larger systems, and we can help you decide what's best for your environment. In terms of predictable low latency, I want you to look at this chart. This was run by one of our customers. And on the top here is Cassandra plus Memcached, so they had a caching system on top of Cassandra. The first thing to look at is the spikiness, is what I call it. You can see those large changes in the latency that go on throughout this test run. So that's one thing to look at. If you look at the bottom, when you're looking at Scylla or in Scylla Cloud, there is no spikiness. The second thing to look at is the magnitude. So if you look at the numbers here, you can see that the Cassandra and Memcached latency kind of ranges between 10 and 30 milliseconds, whereas the Scylla's latency is consistently below 10 milliseconds. And you can see some of these numbers summarized on the right. In terms of Cassandra compatibility in the Cassandra ecosystem, on the left is how you would write an application and connect to the database in Cassandra, and on the right is how you would do it in Scylla. You can take your same clients and just connect to a better, faster database using Scylla Cloud. Now, because we're Cassandra compatible, other applications that you can acquire that I've listed just a few on the left will work with Scylla Cloud as well. And on the right side here, in terms of drivers, depending on your programming environment, you automatically get the drivers that are available today. In addition, we have optimized the Java and Go drivers to take advantage of our underlying implementation. This will give you even faster performance than using the standard drivers. And all of this is available with Scylla Cloud. In terms of no lock-in, you can run Scylla whether on-prem, on a cloud provider of your choice, or as Scylla Cloud. You can easily move the database, move your applications depending on your various business needs. You can't do this with products like Amazon's DynamoDB or Google's Cloud Bigtable. You're limited to where you can run, which is on their infrastructure, and you can't even move it to other systems. In addition, if you needed to, because we're Cassandra compatible, not just at the API, but at the file level as well, at the database level, you could move back to Apache Cassandra if you needed to, and then back into Scylla Cloud or various Scylla products at another time. So there's no lock-in. you get to choose where you want to run the best performing NoSQL database. Now, in terms of Amazon running against Amazon DynamoDB, benchmarks we've run, and there's links down here to the benchmarks that you'll get, we are 1/10 of the cost of DynamoDB while we're remaining at 1/3 of the latency. Okay, so let me explain a little bit more about the details of this benchmark. So let me talk about how we actually compare to DynamoDB. So we ran a standard benchmark called YCSB. We used workload A, which is 50% reads and 50% updates. Now, since DynamoDB requires that you choose a SLA in advance, we chose 60,000 write-ops and 60,000 read-ops per second at a 10 millisecond P95 latency requirement. The data set we used was about 1 terabyte. And to get that performance, we decided we needed to use i3 8x larges, and we used a replication factor of 3. So let's see what the benchmark showed running this type of workload. Okay, so that we used what's called a uniform workload, which hits each of the partitions approximately equal. This is kind of uniform across the partitions. And what you'll see here in the first line is that we both achieved the required SLA of about 120,000 operations per second. However, look at the bottom here. These latencies, whether 95th or 99th percentile, were between 1/3 and 1/4 of what DynamoDB could deliver. You can see the numbers here, and this is actually reported by the benchmark itself. All the other numbers are within certain ranges. But here, definitely, we are much faster with predictable and faster latencies. But what happens when something goes viral? In this case, there was an Academy Award selfie that was retweeted millions of times, and basically this broke Twitter. One of the partitions, what they were using, literally stopped working. In the real world, this can happen in many cases. There's always something unexpected, and the question becomes, what happens and how often is a high volume of traffic going to break your database? You really don't want this to happen because then it affects everything else in your system. So this is called a Zipf-ian workload pattern, where one partition gets a tremendous amount of more data than the other partitions. So when we change this type of workload pattern, what you'll see here is that we were able to keep up the 120,000 ops per second, but DynamoDB went down by about a factor of 2, down to 65,000. That's really not acceptable if you've purchased a certain level of performance. And we did this with twice the performance, even while the latencies remained considerably less than what DynamoDB offered. Okay, you can see that at the bottom here as well. So what's happening here? Well, in a provisioned system like DynamoDB or others, you purchase a provisioned amount, and then that is split between the partitions equally. But if one partition gets hot and hits that provisioned amount, the performance will drop dramatically, as we just showed you. So what do? Well, you have to go get a new provisioned amount just for that one partition. And what happens here is then the partition can grow in performance, but you're paying for a tremendous amount. You're paying a tremendous amount of money for extra capacity that your other partitions are not going to use. This is a significant waste of money. So what's the cost of the hot partition? Well, we ran this benchmark again, and you can see here that although the Scylla performance was less, down to 20,000, because we were hitting one hot partition, look at what happened to DynamoDB. It was under 1,000 ops per second. And this is truly not acceptable if the original goal was 120,000 operations per second. That is less than 1% of what you provisioned for. It's not only Amazon DynamoDB. What we have seen in recent benchmarks against Google Cloud's Big Table is something similar with a hot partition. We were able to keep the 20,000 ops per second, while Google Cloud Big Table went down to 114, significantly less than you would have expected. And look at the latencies at the bottom. We were able to have tremendously lower latencies than Google Cloud Big Table itself. Okay, now what I'm going to do, we're going to go over to a demo with Zach. So Zach, please take it away.
Hi guys, I hope you can hear me. If not, it's going to be quite boring for you in the next few minutes. So what I'm going to do, I'm going to demo launch a new cluster in AWS on Scylla Cloud. I'm going to connect to it and work with it. And then I'm going to talk a little bit about different deployment options that you have on Scylla Cloud. And the last thing I'm going to cover is migration to Scylla Cloud. So this is the Scylla Cloud application. It's live on the web. It is there for a few months now. So if you want to jump into cloud.scyladb.com and launch a new cluster yourself, you can do it right now or in parallel with what I'm doing. So let's see how to do that. So cluster name, let's call it Zach new v2 or whatever. Allowed IP is important. It's a list of IP which are whitelisted to connect to the cluster. By default, it will give you the IP of the browser. In production, you probably want to provide the real IP here of your application and maybe of your browser as well, so you can connect from your laptop. But please do not use 0000 here or something like that. You will open your cluster to the world. You probably don't want to do that. Next is VPC peering. For those who are not familiar, VPC in general is a service, very good service by AWS that allow you to keep your application, your cluster, in a private network using internal as IP. Scylla cluster itself run on a VPC, one for each cluster and one for each customer. And if your application is running on a VPC as well, you can do VPC peering between the two VPCs and connect to the cluster over private IP. And not only it's very good for security because you are not exposing public IP, the data is also encrypted, and it's highly recommended, and most of our customers right now are actually using that. Scylla version, it's not something you can choose right now. We're giving you the latest and greatest Scylla Enterprise version. By the way, we're going to have a new Scylla Enterprise version in a few days, 2019.1, but that's a different topic. Next, you should choose your instances. So right now, we only have AWS, Amazon as a service, but you can choose the region, and you can, or you should choose an instance. The production instance for Scylla Cloud is the i3 family, which is optimized for high-speed storage. And you have a range between i3 large to i3 16 extra large with 64 CPU, which is quite a strong machine. Very shortly, we're going to add the i3 Metal here as well. If you're only interested in evaluation, you can use a T2 Micro, which is not recommended for production, but if you just need to do a quick test, it's a great option, actually, because it's very cheap. And next, you can choose the default replication factor and the number of nodes. By default, we are providing number of nodes that will be a balance between the availability zones. As you can maybe see in the diagram below, I'm going to talk a little bit about how we deploy to zone in a few minutes. The prices, by the way, that are mentioned here, the cost per hour, it's for on-demand pricing. If you go to the Scylla Cloud website, you will also see the per-year reservation prices, which are, of course, cheaper. In addition to the price per instance, we also have price for the backup storage on S3 and for the data transfer. These prices are actually per usage. So if you don't have, you do evaluation or you're doing some kind of a small instance or a small volume of data, you won't use much and not pay much. So I'm launching the cluster, and it's probably going to take a few minutes because we are launching dedicated instances for each cluster and for each customer, so I'm not going to wait for it. Instead, I'm going to jump to a cluster I already launched a few days ago, which is very similar. In this case, I use the i3 large machine, again on the same region, AWS. I have a list of allows IP here. By the way, I have more than one because I connect from the office and connect from my home. So to make sure I can connect from both places, I added both IPs. I can take action on this cluster. The two actions we have right now is a request to resize the cluster. and delete the cluster. Resize is not completely automated. It means that you ask us for the number of instances that you want to outscale, and we will do it for you. Usually during the night, we will schedule it with you. It's not something that is done completely automatic yet. Jump into the monitoring. There is to make the graph more visible, I put Cassandra stress on it, but it's since it's just for my laptop, it's very, very low. But you can see there is an active monitoring here per minute and such, and you can look at each of the instances. We have read and write metrics and such. Connecting to the cluster, which I guess it's the interesting thing. If you move to the Connect tab, you have instruction of how to connect to the cluster. I'm not using VPC peering here, so I have public IP of the cluster, which I can copy. I have a username and a password. The password is something that is generated per cluster. But once you connect through CQLSH, you can change the username and password for something that you choose. Let's move. I have Java instruction here, Python. We will soon end Golang and other languages. Looking at the CQLSH command, I can just copy the syntax with the user and the password and the right IP, switch to a terminal, and connect to the cluster. And here I can run a CQL command. This is just an example of data. The specific example, by the way, I took it from Scylla University. It's a pet shop example of demonstrate a lot of things, but for this case, I only wanted to demonstrate the fact that I can copy the CQLSH command and use it to connect to the cluster, assuming, by the way, that I did insert my IP to the whitelist IP. Otherwise, it will not work. So let's conclude the demo, and let's move to back to the slides. Michael, can you please share the slides again?
Okay.
And, okay, I see. Thank you. So let's talk about deployment in the cloud. And one example for a customer running on the cloud is a GamGam. GamGam is a very interesting company. They're doing actually a lot of things. One of the things that they are doing that they are running the EdTech business. Those of you in the EdTech business know that latency, and especially tail latency, is super important. And this is one of the requirements that GamGam have for the cluster. Originally, they ran a service on Apache Cassandra 2.1 on AWS on 4 different regions with, I think, more than 60 machines. The throughput is not actually, the throughput requirement was not very high, actually, but the latency and tail latency requirement was high, and they simply couldn't get it with Cassandra, and they did more than one try of tuning, but they simply couldn't get the tail latency to go down. So by moving to Scylla Cloud, not only they are able to use a much smaller cluster, they're using about 20 machines right now. The high percentage latency of 99% latency went below 3 milliseconds. And of course, that's very important. To actually do that on a multi-region and multi-DC environment, you need to use the cluster and the application the right way. And later, I'm going to talk about multi-region deployment and how you should use it from the application perspective. Next, please. And yeah, so I already mentioned the instances, the i3 instances, and the T2 micro, which is only available in hourly price, and it's great for evaluation. Next, please. So before I explain the deployment that we have on AWS, a very, very quick recap of how AWS is built. So AWS is split into regions. Each region is almost completely independent from the other region. You have region in the US, in Singapore, and Tokyo, and such, and most of this region already available on Scylla Cloud. Inside each region, there is what is called a zone. You have zone A, zone B, zone C. Some regions have more zones, some regions have less zones. The latency or the distance between the zone is actually very short. So we measure latency. We did a few experiments of measuring the latency between the zone. We got something like a millisecond between the zone. Just to compare it, the latency between regions can easily get to 100 milliseconds. So it's a huge difference. By default, next please. So by default, the deployment of Scylla on AWS, if you're familiar with Scylla or Apache Cassandra terminology, a data center, a Scylla data center is usually deployed in a region, and Scylla Rack is deployed in a zone. In some cases, some customers do want to have more than one data center per region. It's possible, but the default is a one DC per region. By the way, if you go right now to the Scylla Cloud application on the web and try to deploy in a multi-region fashion, you wouldn't find it. It is available on the backend, but we didn't open it on the front-end side yet. So if you do want to run in multi-region, open a ticket and we will do it with you. Next, please. Next, please. So as I mentioned, if you want to outscale, we try to balance the nodes between the rack. So even in a catastrophic case that one AWS zone go down, you still have, if you're using consistency level of quorum or local quorum, you still have high availability in that case. Next, please. As I mentioned, some regions don't have more than one or three zones. In that case, we will deploy two racks on the same zone, and you wouldn't get the same level of high availability. We are notifying you on the UI if this is the case. Next, please. And of course, the greatest high availability you can get is deploy on multiple regions. As I mentioned, GamGam are doing that and other customers in the cloud. And if you're choosing replication factor of 3 on each of the data center, you actually have 9 replication on the cloud. And how to use such a deployment in a smart way is going to be the topic of the next few slides. By the way, just one thing I forgot to mention, if you're using VPC peering, each of the region will have its own VPC peering. So you actually have to create, to pair VPC peering 3 times, one for each region. Next, please. And then next. So let's assume that you already have an application on AWS, and let's assume that you are already working across the globe in a multi-region fashion. You have an application running on the, for example, US East region, and an application running on the EU region. There is more than one EU region, but that's a simplified deployment. And you choose to have a multi-region Scylla Cloud deployment, which the replication factor of 3 on each region. And the key here, and this is what I want to emphasize in the next 2 slides, is that you should use consistency level of local quorum. For those of you who are not familiar with the notion of consistency level from Cassandra and Scylla, when you specify quorum, it's basically mean global quorum. And when you specify local quorum, it's mean quorum inside the data center, the closed data center. This means that when you're doing a write operation, like in this slide, data is still synchronized to the remote region, and can be more than one remote region, but it's all done in an async way. The application is only waiting for an ACK from 2 out of 3 or 3 out of 4 nodes in the local data center. And this is how you can get the low latency, both on write and read. Next slide. So if you're doing a read operation and you are still using local quorum, as you should, your application only waits for the latency from the close by data center, which, as I mentioned, can be something like 1 millisecond. And if you using a deployment and you start seeing a latency of 100 milliseconds, a common mistake will be that you are using something like quorum. And then your application can wait for read response for a remote data center, and of course that takes much longer. Next, please. This is just a sample Python code of how would you update your application to use Scylla. So token-aware policy is always smart to use. I'm not going to dive into it right now. And this aware policy also smart. And what I want to emphasize here, that you should use the local DC parameter depending on when the application is. So if your application running on the EU region, use local DC EU. And if your application running on the US East region, use local DC US East, etc. And this is how you guarantee, together with the consistency level of local quorum, that you get about millisecond latency from Scylla. Next, please. So let's say you are convinced and you want to move to a Scylla Cloud, but you already have a database running. It may be a Cassandra database or a Scylla database, and you want to migrate the data to the cloud. So how should you do that? So the process is actually very similar of migrating any two databases or migrating to Scylla on-prem. And it's usually take 3 steps. The first step is to update your application to dual write. What do I mean by dual write? The application write to the 2 databases at the same time. So each new element always written to the 2 databases. After some time, so the new data is coming in, but you might have historical data that you want to move between the databases. And this part is called forklifting. And the typical way that we are recommending to do that is using a tool that we are providing, which is called SSTable Loader. SSTable Loader is a tool that scans the file format of Cassandra and Scylla and feed it into CQL. And so you can run it directly on the Cassandra cluster. Usually, we don't recommend you to do that because it might hurt the performance of the region or the old database, which is still active. So the typical recommendation is to do that on an intermediate machine, move the SSTable there and run the SSTable loader there and migrate all the data. This can be a quick process or a very or longer process depending on how much data you have. If you have a few terabytes, probably you can do it in an hour. If you have many petabytes, it can take days and days. And in the meantime, the dual write makes sure that all the new updates, including delete and insert, are updated to both databases. After forklifting is done, 2 databases should be in sync. But what you should do, and this is our recommendation, is to continue both of them running and actually do dual read for some time, validating that the data is in sync. Once you're convinced everything is okay, you fade away the old database and just stop reading and writing from it. By the way, we have more tools and more options to do migration. We have a Spark process for that, and we can migrate SSTable directly. So if you want to hear more about the migration process or do a project with that to migrate the data, we have a lot of experience with it. So we'll be happy to help. And I think by that, I'm switching back to you, Michael.
Okay, great. I want to go back up in the slides for a moment and explain something that is actually quite important, and that is about partitions. So what you have here is with the hot partition is that one of the partitions isn't performing because the provisioned amount is spread equally among your existing partitions. So what you have to do is actually get a new provision amount, kind of ask for that increase so that this one partition can perform. But that new provisioned amount is split between existing partitions. So you may have to actually do this again and again. So all the partitions can now go higher. In this case, let's just say double. But the fact is that it costs a lot more money to do this, where the other partitions really don't need that performance. So I just wanted to make that clear. Okay, what I wanted to just summarize with is ways to get in touch with us and some next steps. So if you go to our website, ScyllaDB.com, you can go to the cloud section, read about the Scylla Cloud product. There's a really great FAQ there that will answer many of your questions, as well as we show you the pricing on our webpage. You can sign up for the Scylla Slack channel, where you can ask our engineers and support personnel lots and lots of questions about Scylla Cloud. You can read our onboarding blog post, which we did recently, which will really explain how to get going and all of the options that you have. And you can take a class at Scylla University. These are free classes that will help you get going, help you learn about the Scylla product, which is the same whether you do it on-prem or in the cloud or for Scylla Cloud. And it's a self-paced system, includes a lot of different material, and we're constantly adding to this. So go to Scylla University and take a look. Okay, so here's just another summary. What I'm going to do now is see what kind of questions we've had coming in. Okay, we have a few questions coming in. So the first one was, what sort of notification will I get for planned system upgrades? We will work with you, the customer, to determine, when you want us to do the upgrade for you. We always want you on the latest version of Scylla Enterprise, and we'll work with you to find the right time to do that. Since we can upgrade in place, we can do that at any time, but we want to work with you on the best time that you feel is best for you. Another question is, how do I know what instances I need for my workload? So this is where we would like you, unless you really have a good idea, we can work with you, contact us. We will have a sizing kind of document or an exercise with you to understand your workloads, your total database size, your performance, the size of the payload, and everything like that to determine what is the right instance for you, including the replication factors that you want. For your needs. Another question is, when will you have Scylla Cloud on Google Cloud Platform and Microsoft Azure? We are working on that. It'll be a few months out. If you need it now, please get in touch with us. Let us discuss this with you, exactly what your workloads are, so we can get something that will satisfy your needs, kind of sooner than later. But please get in touch with us, regarding that. And then the last question I see here is, does Scylla Cloud have materialized views? Well, very soon now, we will be putting our latest release, Scylla Enterprise 2019.1, on any Scylla Cloud implementation, any Scylla Cloud instance, and that will have the materialized views features, really imminently within a week. So that's what we'll do for that. So right now, I don't see any more questions that have come in. So I want to thank you again for attending. As mentioned at the beginning, we will be sending out these slides, as well as a link to the recording, and we will be sending you a variety of URLs that are more resources that you can learn about Scylla Cloud. So again, thank you very much, and have a great day.